In this section, we are going to learn about matrix. So the matrix is actually the data organized in this form. So you can see the example, right? So we have A, B, C, D. All these are considered matrix, right? So now by properly organizing the data into blocks of number, right? This arithmetic operation can be carried out in an orderly and efficient manner. Okay, so the matrix is a rectangular arrangement of number in rows and column. Okay, so this is row and this is column, right? So row runs horizontally and columns run vertically, right? So the dimension of a matrix are stated as m by n, where m is the number of row and n is the number of columns. Okay, so as we can see here, for A, all right, the dimension will be, okay, 3 rows. So we have 3 by 2 columns, so 3 by 2. So this is the dimension, okay, of a matrix. And also sometimes we call it the size of the matrix. Okay, so for matrix B, what is the dimension? It will be 2 rows by 2 columns. Right. So the element inside the matrix, we call it entries, and of course we can call it element as well. Right. So the entries in a row in this matrix refer to row of the matrix, and the entries in the column, right, in this matrix refer to as a column of the matrix, right? So, and the signs, sometimes we call it dimension, all right, is described by the number of rows multiplied the number of the column. Okay, now let's see one example on how we can actually represent the data in a matrix form. All right, so a company manufactures 4 different loudspeaker systems at 3 separate locations. So you can see we have 3 different types of model of loudspeaker system, right? Model A, Model B, Model C, and they are actually at 3 different locations, location 1, 2, and 3. All right, so the numbers here represent the units of the loudspeaker. Okay, so for location 1, it manufactures 332 units of Model A, 280 of Model B, 460 of Model C, right? And for location 2, right, it manufactures certain units of Model A, B, and C, and for location 3 as well. Okay, so for all this data, now we can actually organize it in the term of the matrix here. All right, so we can use the matrix to perform some operation, arithmetic operation, right, which we are going to learn later. All right, so now the columns here, right, give the outputs of a particular model of loudspeaker system. So the column actually represent Model A, Model B, and Model C, right? The first column represent Model A, second column represent Model B, and third column represent Model C. And the row gives the output of models of loudspeaker system manufactured at specific location. All right, so from here, the row actually shows us the location. All right, location 1, 2, and 3. Okay, now let's try to understand some arithmetic properties of matrix. Now, first, when we have equal, right, the two matrices are said to be equal if, right, two conditions, right, the first one, they have the same size, right, the two matrices must be same size, and two, their corresponding entry must be equal. All right, so now let's look at the first one here. All right, the first example here, these two matrices, they are said to be equal. All right, so we must check. There must be two conditions. The first one, all right, the size should be the same. So what is the size for the first matrix? It will be 2 rows by how many columns? 3 columns. All right, now let's check the size for matrix on the right hand side. So how many columns? How many rows? 2 rows. And how many columns? 3 columns. All right, so the first condition has been met. Okay, so they have the same size. Number 2, the corresponding entry must be equal. So it means that the entry for the first row, first column, right, is 4, right? So they are equal. The entry for the first row, second column, -2, so equal. And the entry for the first row, third column is 3, right? And so on for all others entries of the two matrices, right? They must be equal. So let's see another example here. Now for the second example here, these two matrices are not equal. All right, why? Right, first because the signs are different. For the first matrix here, the size is 2 by 2. Where for the second matrix here, the size is 3 row by 2 columns. So as we can see here, the size of the two matrices, they are different. Therefore, they are not equal. All right, let's look at the third example here. Right, the third example here, again, all right, the two matrices are not equal because of the signs. Now, let's see another example. If we have 1, 6, 0, -3, another matrix is 1, 6, -3, 0. Right, are they equal? All right, no, they are not. All right, the reason is, although the two matrices have the same size, but the corresponding entries are not equal, right? This is 1, 1, 6, 6. Now, the second row, first column, all right, this is for the matrix on the left-hand side is 0, but for the matrix on the right-hand side is -3. So the corresponding entries, right, are not equal for the second row. So these two matrices, they are not equal as well. Let's see this exercise here. Right, solve the following matrix equation for x, y, and z. All right, now, so first, the two matrices, they are said to be equal. So we must know that, right, the two matrices, they have the same size, and the corresponding entry must be equal as well. All right, so you can see here, this is 2 rows by 3 columns, and the matrix on the right hand side, 2 rows by 3 columns as well. Okay, so the entry is 1, 1, right? And okay, we can see here 3, 3. Okay, 1, 1, and 3, 3. Now, in this case, so we can actually know what is the value of x. All right, since they are equal, so the x should be equals to 3. And how about the z? The z is equals to 4. Right, and y minus 3 should be equals to 2. So y minus 3 should be equals to 2, and therefore we have the y is 2 plus 3, which is 5. Right, so we call this the matrix equation. Right, so from here, right, since they are equal, and we can find the corresponding value. Right, matrix addition and subtraction. Okay, now we can add or subtract matrices if they are the same dimension. All right, to do this, we add or subtract the corresponding number. Okay, now before we perform the addition and subtraction, so first thing we must check if the two matrices or the matrices they have the same dimension or not. All right, we can only perform the addition and subtraction if they are or they have the same dimension. Okay, so let's take a look on this example. Now, right, for these two matrices, first we check the dimension. The dimension is 3 by 2. Right, 3 rows by 2 columns. And for the second matrix is 3 rows by 2 columns as well. All right, so they have the same dimension. Now we can perform the operation. So to perform the operation, we add or subtract the corresponding numbers. So it means that we have 2 minus negative 1. So 2 minus negative 1, we get 4. We get 3. All right, so this is 3. And negative 4 minus 0 is negative 4. 5 minus negative 2, it becomes 5 plus 2, 7. And 0 minus 1 is negative 1. 1 minus 3 is negative 2. Negative 3 minus negative 3 is 0. All right, so this is how we perform the plus or minus of matrices. Right, first we check the dimension, they must be same. And second, we plus or minus the corresponding value. Right, now the scalar multiplication. Right, the scalar multiplication refer to we multiply the matrix with a number. All right, so this number is called the scalar. All right, so what do we do here? We are going to distribute the number into each of the entry. So 4 multiply the matrix. All right, so it will be 4 times 2, 8. 4 times negative 4, right, negative 16. 4 times 5, 20. 4 times 0, 4 times 1, 4 times negative 3. All right, so now how do we understand this one? Now, for example, right, so this is the marks obtained by the students, right? Let's say we have student 1, student 2, student 3. So this is for mathematics subject, and the other one is for English. All right. So now let's say student 1 obtained, all right, 3 and 5. All right, student 2 obtained obtain 4 and 3, and the student 3 obtain 1 and 4, right? Now, so these are the marks obtained by the students, and the marks is actually over 20, right? The marks over 20. Now, let's say we want to change the overall mark from 20%, all right, now to 100%. So what do? We are going to take this matrix multiplied by from 20% to 100%. So we are going to take this marks multiplied by 5. All right. So in this case, right, so after we change this one, all right, we take this multiplied by 5. 5 multiply 3, 4, 1, 5, 3, 4. Now we have, right, 15, 25, and this is 25, and 15, and 20. All right, so this will be the marks over hundreds. All right, over 100%, and before this is the marks over 20. All right, so we can actually use the scalar multiplication, right, to change the magnitude of the matrix. Let's take a look on the example. Now, given two matrices, right, A and B. Okay, so right, find matrix X satisfying the matrix equation 2x plus b equals to 3a. Okay, so we want to find what is the matrix X. Right, so now first we start with 2x plus b, and this is equals to 3a. Now to find the x, first we move the b to the right hand side. So as usual, when we move the b, it will be minus b. All right, so let's solve this matrix first. So we have 3 times a. What is a? A is negative, 3, 4, negative 1, and 2. Minus the b, matrix b is 3, 2, negative 1, and 2. All right, so by solving this one, now we have the matrix, 2 times matrix X will be 9 minus 3, which is 6. 12 minus 2, 10. Negative 1 minus negative 1. So it will be negative 3 plus 1, negative 2, and 6 minus 2, 4. Right? So we solve the right hand side. So we have this matrix. Now, how about to get the matrix X? We need to bring the 2 to the right hand side. Now, what happens is that when we bring the 2 to the right hand side, it becomes 1 over 2 of this matrix. All right, so we are going to make it 1 over 2, right? So since the 2 bring over here, so we have 1 over 2 multiply 6, so it's 3, and 1 over 2 multiply 10 is 5, 1 over 2 multiply negative 2 is negative 1, 1 over 2 multiply 4 is 2. All right, so therefore we have the matrix X now, right, is 3, 5, negative 1, 2, right? So this is the matrix X. Now, next, we are going to learn to multiply two matrices. Okay, so now when we multiply two matrices, right? First, for the first matrix, we are going to perform the operation according to rows. All right, according to rows. And for the second matrix here, we are going to perform the operation based on column. All right, so it will be row multiply column. All right, so when we multiply, this is what we do. We are going to take the first entry, multiply with the first entry. Okay, and we're going to take the second entries of the row, multiply the second entries of the column. All right, and after that we sum. Right, we sum the product. Now let's take a look on the example here. Okay, so when we multiply these two matrices, I'm going to start with the first row and the first column. So start with the first row, first column. First number multiply the first number. So 4 times 2. So we have 4 times 2 here. And after that, the second entry multiply the second entry. So we have 2 times 3 here. Right? Now, after that, what do? We sum. Right? We sum the product. So this is 8 plus 6. So we have 14. Right? So the 14 is the sum of these two products. Right, now after that, what do? Now we are going, after we complete the multiplication for the first column, so we are going to now move to the second column, remain the first row. So move to the second column. Again, we repeat the first entry, multiply the first entry. So we have 4 times 1, right? 4 times 1, and 2 times 2. Okay, so, and after that, we sum this, right? So we have 4 plus 2, 4 plus 4, 8. All right. Now, after we complete the second column, now we are going to move to the third column. So repeat the same operation, 4, 0 plus 2, 1. All right. So we have 0 plus 2, which is 2. Right. Now, we have already completed the first row, right? Multiply the first column, second column, and third column. Now, we are going to move to the second row now. So we move to the second row. So we are going to repeat the same operation where you take the second row. Now we multiply the first column. 3 times 2, 1 times 3. And we sum. So we have 6 plus 3, 9. And after that, move to the second column. 3 times 1, 1 times 2, right? And some days we have 5. And after that, we move to the third column. 3 times 0, and 1 times 1. And so from here, we have 1. All right, so this is how we perform the matrix multiplication. Now, matrix multiplication is not commutative. Now, what is commutative? All right, now for numbers, we know that 3 times 2 is equals to 2 times 3. All right, so it means that A times B is equals to B times A. Now, we call that commutative. Now, however, for matrix, the multiplication is not commutative, right? It means that matrix A times matrix B, it is not matrix B times matrix A. All right, so A multiply B is not B multiply A in matrix. So we call that it is not commutative. All right, so now before that, right, for two matrices to multiply, all right, these two number must be matched, right? They must be the same number. All right, so if the two numbers here, they are not equal, right, we cannot perform the multiplication. Now, let's take a look on this example here. All right, so you can see here for the first matrix is 3 row by 2 column, right? 3 row by 2 column. And the second matrix is 2 rows by 2 column. Right, now when we have the two number here equal, then we can actually multiply these two matrices. So we start with the first row for the first matrix and the first column for the second matrix, right? First row for the first matrix and the first column for the second matrix. So what we do is we are going to take 2 times 1, 3 times 9. All right, so 2 plus 27, so we have 29. Okay, so we can perform the multiplication. All right, now take a look on the example below. Now for the second example here, we cannot perform the multiplication. All right, the reason is for the first matrix here, all right, it's 2 by 2. There are 2 columns, but for the second matrix, there are 3 rows. All right, so these two numbers, they are not matched. All right, therefore, we cannot perform the multiplication. Now, let's try and see if we perform the multiplication, what happens. Now, if we perform the multiplication, so 1 times 2, 6 times -5, then we have an extra number here, right? Which makes the matrix, right, can not define, right? So we have to check the number in order to perform the multiplication. If they are same number, they are matched, then we can actually perform. If they are not the same, we cannot perform the multiplication. All right, now, maybe some of you noticed that, right? The two examples here, they are actually the same matrices. All right, let's take this matrix as matrix A, and the 2 by 2 matrix as matrix B. So for the first example, we have matrix A times B, A multiply B. Now, A multiply B, it is defined. All right, the matrix is defined because we can actually perform the multiplication. Now, for matrix, for the second example here, the first matrix is B, the second matrix is A. And you can see here, all right, this B multiply A, the result is not defined, right? We can't multiply actually. Okay, so from here, we actually know that, right, the AB is not equals to BA because AB is defined and BA is not defined. And also from here, we know that AB is not BA, right? And the matrix multiplication, they are not commutative. Okay, now if we multiply the two matrices, all right, the result we get will be actually, right, the combination of these two numbers. Okay, so before this, we mentioned that we have to check these two numbers. They must match, same number, then only we can perform the multiplication. And the result of the multiplication, right, the signs is actually the combination of the first column and the second, sorry, the number of rows from the first matrix and number of columns from the second matrix. All right. So let's try to multiply these two matrices. All right. So we have, right, start with the first row, multiply the first column. All right. So we have 2 plus 9, 11. All right. So after that, move to the second column. So -4 plus 12. So we have 8. Right. So, and then, right, move to the third column. 0 plus -15. So it will be -15. All right. So after we complete the first row, now we move to the second row. All right. Come back to the first column. Okay, -5 plus 18. So it's 13. All right, then move to the second column. All right, 10 plus 24. All right, so it's 34. And move to the third column now. So we will have 0, -30. All right. So after we complete the second row, now move to the third row and come back to the first column. All right, we have 9 minus 21. So it's -12. Right, and move on to the second column. -18. -28. Right, -46. And now move on to the third column. All right, and we have 0. All right, 35. Okay, now we can see here the result we get here is 3 rows by 3 columns. Right, we have 3 rows and 3 columns. All right. Now, alternately, we can actually solve these questions by using this method. All right. So, right, by using this method, so first we take the first row and we put here. All right, and second row, put to the second row, and the third row, we write here. And for the first column here, we write here, and the second column, and the third column. All right, so when we perform the multiplication, so this is what we do. Okay, so we take 2 times 1, all right, 2 times 1, 3 times 3. And we sum, so we get 11. So after that, right, take the 2, multiply -2, yeah, and 3, multiply 4. All right, and sum it. Okay, and after that, so we are going to take the 2 multiply 0 is here, and 3 multiply -5 here, and we sum. All right, so now after this, then we move to the second row, right? -5 and 6, right? Repeat the same thing. 5, -5 times 1, and 6 times 3. All right, and we sum this. Right, so just perform the multiplication repeatedly to the corresponding uh, row and column, and we can get the answer. Okay. All right, we're going to discuss this one, all right, in the lecture. Okay, now let's take a look on the application example here. Okay, so this is about the stock transaction, right? Judy's stock holding are given by the matrix. So this matrix shows the stock holdings of Judy. All right, so Judy has 700 units of GM, right? GM is a company, right? It should be the General Motors, right? It's a car manufacturer. Okay, so also Judy has 400 units of IBM. It's a computer company. All right, and she also has 200 units of BSC. All right, so now at the close of trading on a certain day, the process of these stocks are, all right, so the matrix B shows the price of the share, right, per share, right, price per share. Now the 50 is for GM, right, and 120 is for IBM, and 42 is for BSC. All right, so this value shows the price per share, right? So what is the total value of Judy's holding as of that day? Now, how do we calculate the total value, right? So it will be, now, let's say you have 700 units. Judy has 700 units of GM, right? This is the quantity. And the price of GM is 50 per unit. So what do? We're going to multiply, right? So we have 35 and 3 zeros, so it's 35,000. So this is how we calculate the value, right, of Judy's holding, especially for GM in this case, right? Now, if we want to find the total value, so we actually need to perform the multiplication for these three shares, right, company, right, GM, IBM, and BSC. Okay, so is that possible? We just perform in a single calculation. All right, so here comes the matrix method. Now, according to the matrix method, we can actually, right, perform the multiplication in this way. Okay, so as you can see here, this is the matrix A. So this refers to the quantity, all right, of share of Judy's holding, right? So the share that Judy's has, right, at the moment. And this matrix B here refers to the price per share. All right, the first one is GM, the second one is IBM, and the third one is BSC. Now, to find the total value, so right, we are going to take the quantity multiply the price, and the second one, the quantity multiply the price, and the third one, BSC, quantity multiply the BSC price. All right, so we have 700 units multiply 50 per share, 400 units multiply 120 per share, plus 200 units multiply 42 units per share. So sum this up, we get 91400. So Judy holdings the total value of Judy's holding is 91,400. Okay. Now, next, we are going to learn, right, how to use the matrix representation to solve the system of linear equation. Okay, let's take a look on this example here. Now we have a system of linear equation here with 3 variables, 3 equations. All right, so we have x, y, z, 3 variables, and now we have 3 equations. So first, we can actually change this system of matrix equation, sorry, system of linear equation to matrix equation. So this is how we change the equation to the matrix form. All right, so first we are going to take the coefficient of each variable. Now, what is the coefficient? The coefficient is the value in front of the variable. All right, so for x, the coefficients are 2, -3, and 1. All right, so these are the coefficient for x. And the coefficient for y are -4, 6, and -3. And the coefficient for z, okay, is +1, -5, and +7. All right, so the coefficients of the variables, all right, can form a matrix, right? So we let this be matrix A. And the variable itself, we can form another matrix, the matrix of variable, which is x, y, z. All right, and finally, you notice the result after equal, all right, after equal sign, this will form another column matrix as well. Okay, when we put these 3 together, all right, now you can see here when we multiply matrix A with x, so this is what we do, right? First, we are going to take the column, sorry, we are going to take the row, right? First row, then we multiply the column. Okay, the first row, we multiply the column. So we have 2 times x, therefore we get the first, right, 2x here, right, 2 times x, -4 times y, -4 times y, and 1 times z, 1z equals to 6. All right, so when we multiply these 2 matrices, all right, we will get back the 3 equations here. Okay, so multiply the second row to the column matrix. It will be -3x, right, which is this one, 6y plus 6y, and -5z. So we have -5z is equals to -1. All right, and finally, all right, we take the third row, multiply the column matrix. It will be 1 times x, 1x, -3y, plus 7z is equals to 0. Okay, so as we can see, right, so when we multiply the matrices, matrix equation, we are going to get back the system of linear equation. Okay, let's do some exercise here. Okay, so write the given system of linear equation in a matrix form. Okay, so to convert the system of linear equation to a matrix form, first we are going to take the coefficient of the variable. So the coefficient for x will be 3 and 2. Therefore, we have 3 and 2. This is the coefficient for x. Now the coefficient for y, we can see here we have -2. But the second equation is nothing here. So what is the coefficient? Okay, nothing here. The coefficient is plus 0y actually. So we can actually write -2 and 0. Alright, so even though it is nothing, but right, we know that it should be plus 0y. Alright, then the second equation will be the second matrix will be the variable. Alright, so it will be x and y in a column arrangement. And the third matrix after the equal sign will be the result. It will be 12 and 7. Okay, so if we multiply this, we are going to get back the same equation here. Okay, so we have 3 times x minus 2y equals to 12. So this is what we get. 3x minus 2y equals to 12. All right. Now, how about this one? Okay. The second matrix should be the variable. So it will be x, y, z. Right, we have 3 variables. And the arrangement must be in column arrangement. Now, how about the first matrix? It will be the coefficient, right? 1, 3, 2. So we're going to put 1, 3, 2. And the second column will be -2, 4, -3. And the third column will be 3, -2, 7. All right, and of course, for the result here, right, it should be the matrix C behind. All right, so it will be -1, 1, and 6. Right, so this is how we convert the system to